In this video, you will finally learn to run tasks in the background of your Capacitor applications. Hey everyone, what's up? This is Simon from the Ionic Academy, and in this video, I'm going to show you how to use the new Capacitor Background Runner plugin. This plugin is super cool as we can create our own runner JavaScript implementation and run tasks in the background of our iOS and Android application. There are actually two ways to use this. The first is to directly dispatch an action from our application to that background runner. The second one is to let the system run this at specific time. And specific is not really specific because iOS and Android will treat this more like maybe you could run our task at some point, but they won't do it on the minute or even the hour. So this is not a plugin you can use to directly schedule some background action at a specific time. However, it is still impressive, and I'm going to walk you through all the steps that you need to take to integrate the Capacitor Background Runner. Alright, so let's see how we can integrate background tasks in our Ionic application using Capacitor, or how you could do this with Capacitor in pretty much any JavaScript web application. I started, in this case, with an Ionic Angular application, and I installed the Capacitor Background Runner package. I don't know if this will be the final name because it is still very fresh, so maybe there's a different name in the future. You can check this out in the Capacitor documentation. So the background runner here is the star of the video today. We want to install this, and there are some things that we need to configure about iOS, that we need to configure about Android, and that we should say in general about background tasks, because this is not the cure for all your problems, and it's probably not going to work as you expected. But I'm going to talk you through all of that during this video. To get started, what we need is a new file. I'm going to put this in here. So I'm going to create a folder utils and put in a runner.js. Yes, I tried using TypeScript, that kind of failed, so I will stick with a runner.js. This is the file in which we're gonna implement our background tasks. To give you a quick overview, those tasks could look basically like this. We're having an event listener for some sort of event that we can trigger, and then we have a block. So this is an example of a runner.js file. We won't do this right now because there's still some things that we need to set up. So in order to include this in our final bundle, we need to go to the Angular JSON file, and we need to head down to project, app, architect, build options. So basically the first thing that comes to your eye here, and then the assets folder. And here we can already see it's copying some stuff, and we want it to also copy our file. So we want to copy our runner.js. The import folder for this is source app runners. So be careful if you put this or place this anywhere else in your application. You see, I already made the mistake of I called this source app runners, and I'm confused because I think I previously called this runners. Yeah, that makes more sense. So source app runners, as you see, don't get confused with that stuff, and then define the output as simply /runners. So let's see if this actually works. I can now run an Ionic build, and that should generate our Angular build of this application, and it should hopefully include our runner.js file, and it should be available at the output /runners/runner.js. At least that's my dream. Let's see. There we go. www.runners/runner.js is included. Now, that was the first step in our journey, and probably the most easiest. What we need next is to dive into the Capacitor configuration. Now, in the Capacitor configuration, we need to add a new object for plugins. And here we're gonna define for background, not background tasks actually, but background runner. And in here, we define where our background runner, our file lives, and how we can use it. So most likely you're gonna have a different app ID. So let's call this com.academy.runner, doesn't really matter. And we wanna use this for the label in here as well, with one addition. I'm gonna call this check, like this will be my background check. So I found that at least the first part of my background runner has to be the same like the app ID. Then we're gonna have to specify the source. So where can this background runner be found? In our case, it's under runners runner.js. Then we're gonna specify a specific event that should or could be called. And we're gonna see a difference about this later because we can actually manually call this event. So in sort of like a worker fashion in the background, or let this be scheduled by the system. And what we define in here is the system way. So we can tell iOS and Android to please repeat this event in the background. We can give this an interval. And this is, I think, in minutes so far. And this is really like, I would say, at most a recommendation. I tried this with a minute, I tried this with 5 minutes, and iOS pretty much just called when it wanted my task. So don't think this will call on the minute your background task every 30 minutes. Additionally, we can specify an auto start here. So that simply means whenever my app goes into the background, it will automatically start this background runner task and schedule it in the system to be called. So in the case of, let's say we would have this custom event here. If I had this custom event in here, I would say, okay, please call the event my custom event when we go to the background. That is our general setup. Now, we also need to configure the native iOS and Android platforms. I think I haven't added them yet, so let's quickly do this. I should have the scripts here, right? Ionic cap add iOS and Ionic cap add Android. That will add the native iOS and Android platforms to my project, and it will also already install the plugin. So you're gonna see right here, it's installing the background runner, currently version 1.0.5. Because this is a native plugin that is used to actually schedule our task. And we can actually take a look at this. Let's see, cap open iOS. Under iOS, we can find my pods here, and we can find the development pods, we can find the Capacitor background runner, and then you can have a nice peek into what's going on with your background task. So under the hood, this is really using the native iOS background runner, and you're gonna find the same implementation online. So this will be an important line that we come back to, the shared submit function here, as we can debug at that point and dive into our application. However, what we need to do is we need to change some files in here. We could also do this from Visual Studio Code, do whatever you prefer. We need to go to the app delegate, and in the app delegate, we're gonna add imports up here. So we got UIKit and Capacitor, and I want to import background task and the Capacitor background runner. When I tried this, this was actually not specified in the documentation. So that's when I tried to change those lines in here, it failed because that actually didn't exist. So make sure you update the import, make sure to update the did finish launching with options up here to register the background task and handle the application did finish launching. Additionally, if you want to capture remote notifications, push notifications in the background runner, you have to update the application did receive remote notification. Is this already in here? Did receive? No, it's actually, I think it's not even included. So there's a full function that we need to add. And of course, that is also mentioned here in the docs. For iOS, at least I think so, yeah. So add the following function that we see right here. Now, this is the first step. Second step is to give permissions correctly. For this, you might know that there's a file called plist, an info plist. Now I'm opening this in Visual Studio because I really like this more in here. So this is in our iOS app info plist. And what we need to specify in here are different, a few different things. So first of all, we need to specify the background task because that's not specified yet. So let's add a key. And once again, this wasn't described at my time checking out the documentation. So we need to have a key background task scheduler permitted identifiers that simply tells iOS, okay, these tasks are allowed to run in the background. And that's going to be an array with strings. So this gives us a nice example. However, of course, we want to use now the exact label we used for our background runner. So let's replace this. Okay, and that's good. Additionally, our background runner has access to notifications, geolocations, data fetching, and in my case, I want to use the background location. And if I want to use the background location on iOS, I of course have to add these fancy names and as location always when I use it and yada yada yada. So make sure you add them in here as well, otherwise your app won't work. The same is true for Android, by the way, and we're going to the Android manifest file, which you can find under Android app source main Android manifest. And in my Android manifest, I will scroll down to the permissions internet, and I'm going to add a few more permissions down here. So we have course location, file location, schedule for scheduling notifications, and also our hardware location, GPS, for the map that we later want to add. This is now almost everything. Apparently, it's not completely everything. So there's one more step for iOS. So under signing and capabilities, we now need to add the background modes capability. So from this list, click add capability up here and then select background modes. So I'm going to add this. You can actually also do this right in the info plist. I noticed this afterwards. Let's try to add something. So if you check this out, can we zoom into Visual Studio? No, of course not. There are different modes that you can or want to allow. So I just want to have background processing, background fetch. I want to have location updates enabled, and I think that's pretty much it. Maybe you also want remote notifications, but that's up to you. If you now go back to the info plist, you're going to find a new entry called UI background modes. So in theory, we could have done this from code in the info plist as well. However, I just wanted to show you how you can add those background modes in Xcode. For iOS, for Android, there's nothing else as far as I know we need to do. So we can now close these files and we can actually implement the background task. Isn't that cool? It just took us like half an hour to implement the setup, but that's the problem. It's quite challenging to implement all of this. So under my runner.js, I will now add two events. I'm going to add a new event. I'm going to change this to a test save. And what I want to test is I want to try and write the capacitor key value storage, which we have available here. So I'm going to wrap this in a try catch, and I'm calling capacitor key value storage dot set. So it's pretty much the same, API like the capacitor preferences plugin. However, in my tests, I couldn't use the capacitor preferences from my app to access the values that the background runner set because they live in their own context. In theory, I still think this should work in the future, so maybe it's going to work at some point. But let's try it like this. So I'm going to try and set this, and I'm going to catch any error that might come up, and then reject this. So we always need to resolve or reject our call to the plugin. So this is a very simple implementation, and I could now do the same for, let's call this test load. And I want to get the value for foo, and I will resolve with the value. So we should probably say const value equals something, putting in the value here, and then we have our runner. Now let's see how we can call this. We go to our homepage here, and first of all, I'm going to import the background runner from capacitor background runner. Then we probably should set up an according initialization function because our background runner will, at least in like a few minutes, require location and notification access. So once we need that, you have to request the permissions up front. So I'm going to say permissions equals await. So I'm going to make this an async function. Await background runner dot, and then we only have a few here. We got check permissions and we got request permissions. And to request permissions, I can now pass the different APIs that I want to have. So actually there are only two at the time creating this: geolocation and notifications. Okay, so I'm going with that. Now we could actually log this out afterwards, and I can also catch any error and display this in case it comes up, and then call my init function in here. Now, how do we call the background runner? As I teased before, there's a mode where the OS, Android, iOS will call this automatically in the background. But to test things right now, we want to directly dispatch something to the background task. And actually, that is a very common thing. Like you got a service worker in the web that you can put stuff onto, and you could use your background runner to execute that stuff in the background. That's actually a pretty legit way of using it. So let's call my test save first. And with my test save, I will try. So let's say const result equals background runner, and we know there's just a very slim API. So I'm going to dispatch an event, and I will dispatch an event. The label is now once again and I want to make sure that this is correct. Yeah, com academy runner dot check. That's what I called this. Okay, yeah, making sure everything's aligned. Then we got the event. In this case, the event name is test save. And then we have also some details that we could pass. So you could actually pass some parameters to this. In case you do like some kind of background processing, then you could put like the input values to this background task. Cool. If we have a test save, we can of course also have a test load. That test load would look pretty much the same, only that we in this case dispatch the test load event. And with that in place, we're actually ready for our first task. So let's do Ionic cap build iOS. I'm going to test this on iOS. Will I test this on my actual device? Yeah, why not? Why not? So in Xcode, it should come up real quickly. I'm going to select myself. Yes, please read this from disk. If you want to deploy your application to a device, you have to be enrolled in the iOS developer program, I think. And on the iOS simulator, I think, as far as I know, the background modes don't work correctly. So keep that in mind, that you probably want to run your app on the device. So here is my app. Background app will like to send you notification. This now already comes because we try and request permissions in our application. So putting this to the side, our initializer runs. We want background location, and yes, I also want to do this. I don't know why I can't say always, because I actually want to like do this all the time. So I'm going with allow while using. Now, of course, I completely forgot about adding some buttons to our page, so we can't really call this. Let's quickly do this. I'm going to add a new button in here. Let's get rid of all the stuff. Let's change my header and let's remove this. Okay. And then once again, quickly running the cap build iOS. I don't know if it would work if I had reload and live reload enabled. That could probably cause some issues if we just load the remote app. So I'm not taking chances. I will simply redeploy my application, and then we can inspect this. So we can use my inspect tool, which I usually use for inspecting my device. So here is my app. Here's the inspection tool. You can also do this with Safari. Now let's try to save values. Okay, this results in undefined. Not too bad. Let's try to load values. And there we have it, our first confirmation. This is good news. Like, I'm generally getting excited about this, and people are like, wait, you're pressing a button and then you see a value. Like, that is not magic. But this comes from the Capacitor key value storage. We call it the test save, so I could also have passed some kind of details to this. I could have done some work. And once I call this other runner, I got back those values, which were my test bar. So this is what we exactly wrote to the Capacitor key value storage. Again, if I could now also just use Capacitor preferences in here to load the result, that would of course be even better. But I think this is a good start, and it shows, first of all, that we have finished the first step of integrating the background runner plugin, the file, the permissions, and everything else related to making this work. And now with this base in place, you can build on this and we can do some cool more things. The first addition is now to explore what we can do with the runner. So far we've seen the capacitor key value storage, but we can also fetch data in the background, use notifications, or use the geolocation. I'm going to use the first two of them. So let's see, we could easily add a simple fetch to an API, just like this. So we're adding a new event listener fetch test, which will make a fetch call to the random user API, and then it will return and resolve with one of those results. Nothing too fancy. On top of that, we could also add a cool schedule. So a schedule with capacitor notifications. You can see we don't have to import anything in here. This is all done internally by the background runner plugin. So it is kind of a bit of magic, and I think in future versions we might see like a different way of using this and making this more transparent to which APIs you got access. Because as you can see, if you just use JavaScript, then we have this capacitor key value storage, we have fetch, we have capacitor notifications, but it's not really that obvious. So this notification test will nonetheless use the capacitor notifications to schedule a local notification. Remember, this is a local notification, not a push notification. And also remember, I did not install the local notifications plugin. So if this works, that would actually be quite interesting. So let's add two more functions to our homepage so we can actually call them, and again they will follow the exact same setup. So background runner, dispatch event, and then dispatch the event name. So only the event name actually changed. We could have probably done all of this in one function, but well, that's life. Okay, I'm gonna add a user. I'm going to say any null, so perfect TypeScript usage in here. And once we get back this user from our fetch test, we will assign this to our value. Now, with that in place, let's also head over to the homepage HTML, and let's add a few functions here. So we now have the perform background fetch and the schedule notification buttons, and I also added this additional block down here. If we do have a user, we will display it. And remember, we're not doing the HTTP or fetch call here in our application. We are actually doing this in our background thread. So here's my app once again. So I will kill this and restart the application. And once this is done, let's see, is the app up? There it is. Oh, we probably want to debug again, right? It's always nice to see the background, what's going on. So let's open inspect. I don't know if I added any logs, but nonetheless, let's try. Okay, we already had the load and save values. Let's try to perform a background call. And boom, we got something. So this was now called in the background. We see the whole data object. This log message comes from... There's no log message in here, so it has to be the runner. Yes, where do I log this? I think I never logged this, but we see this event nonetheless. Yeah, as we resolve the event, this data is returned, and then we see the email is displayed here, and the name stuff is displayed here as well. And I can also, of course, perform that background call again, and it would always make calls in the background. And you could already think about things that take too much time in your application, in your JavaScript, in the front end thread, then you just want to execute this in the background and it will come back at some point. Now, we don't really have another mechanism in case this takes really long. Usually your background task should be like 30 seconds long. So keep that in mind when you do something. Now, let's also try to schedule a notification. For that, I think I have to leave the app. So I'm going to leave this, and usually this is going to appear on my watch. I think whenever I do like the screen mirroring, it's not working, right? Yeah, I think that's going to be the case. So there won't be any notification in my notification bar. That's actually a pity because it looks so cool whenever it comes up there. Actually, I still got proof. So here it is, background magic. This comes from the background runner. And when you run this code, you will see it on your device that this actually works and schedules a background notification. So With that in place, we have now covered some of the basic use cases of the background runner. We have the capacitor key value storage, which we can use. We have the capacitor notifications, and we can make fetch calls. Now, there's one more thing that I wanted to show you, which is around geolocation. And this is not exactly how I wanted it to be, but nonetheless, it works pretty good. So let me talk you through what we're going to do. I will first add a new page to my application, so Ionic generate page map, or if you're using React, you could just manually add that page, and then I will install the Capacitor Google Maps plugin. Now, why am I doing this? Because I want to get the location of my user here in the background runner, and I've wrote a somewhat complicated check-in function. Let's walk through all of this that happens here. So in theory, this function should be called periodically in the background while our app is not active, and it should be started automatically by our plugin. So therefore, I'm going to change my background runner event here to the check-in, and it should repeat every 30 minutes and automatically start once I close my application. That is the idea. What this will do is it will grab a check-ins value from my key value storage. It will then get both the current time and the current geolocation. So we see this is now the fourth API after the key value storage and the capacitor notifications. We also have the geolocation. It will then create this example object in an array. In case we already had data in our array in the key value storage before, it will add that to the array. Otherwise, it will use the new check-in array and write that as a stringified version back to the capacitor key value storage. So basically, it's being called, it gets the time and the location and writes it to the key value storage. That is the whole idea of this. Now, I wish this would be called every minute, every 5 minutes, we can like track the user completely, but that's just not the reality of how background tasks work. If you read about this, you will find out that on iOS, it's maybe called every 5 minutes, it may be called in 30 minutes, or it's maybe called in 5 hours. So in my tests, I've seen really strange behavior, and it's basically that iOS is trying to schedule your stuff at the best time. So if you're using an app usually around noon, it will also like mimic that behavior with background tasks or do it at a different time. So it's really complicated. You can't rely 100% on the dates that you set in here. Nonetheless, let's follow this up with the load check-ins, which will do the same as we did with our load test before. So it will grab all the check-ins from the key value storage, parse them, and call resolve so we can actually access the data from our page. Now, we don't really have to go through the integration of a map. I will just outline the steps. There's another video, I think even on this channel, about using Capacitor Google Maps. Basically, you add your custom, with Angular, the custom elements schema to the module. Then to my map page CSS, I'm going to add a bit of CSS, and I will also make the Ion content background use none, because you're gonna run into problems as the Capacitor Google Maps is usually behind your content, as it's really a native view. Then I'm going to add a view where we will host the Capacitor Google Maps and the button and a list of all the check-ins that we have stored. And then I will follow this up with the actual map page. So we're really going through this quickly just to demonstrate what's going on, and you can find the code below this video. There's something more interesting that I want to show you in a second. So this would be my map page. It will create the Google Maps. You have to plug in your own API key. So I'm going to use my key now and expire it after this video. And then we have a load check-ins, which performs once again a new function to load check-ins. We need to be careful. I think I reused a different name this time. So be aware, it should be this right here. So on my map page, yeah, that can cause really ugly problems. Make sure you got the right labels. And then we'll create an array and add those markers to my map. Nothing too fancy actually. But the interesting thing is how we can now debug and schedule this stuff. By the way, quick note, for Android, you gotta open up your Android manifest, and in the Android manifest you gotta have to add a new entry here under application, which is also using your API key. So I will just now follow up with iOS, but for Android and Google Maps you would have to add your API key in here. Okay, with that in place, let's build our iOS application, and now we're getting into debugging this. So this is getting interesting now, because you don't really want to wait until iOS at a random point calls your background runner. So if you want to debug your runner, there's actually a way to do it, and I'm going to show you how. So in the Capacitor background runner, this is where we want to go. There is a line around line 70 something right here. So here we got the shared submit request. This happens when our app goes to the background. It will schedule this. I can also set a breakpoint here, and then I'm going to say scheduled task, whatever. And the important part is I'm going to set another breakpoint here. That first breakpoint is actually, we don't really need that. Let's see if I know, where's my app? Is the app actually running? Yep, app is here. Oh, I forgot to add a new button so we can see our map. Perfect. Let me quickly get that right. So under my home page, I want to add that button and then doing another build. Apparently, while we talk about debugging our background runner for Android, I haven't found a great way to do this. The only way I found was actually to just show the task. So in Android Studio, let me try to get this up here. In Android Studio, there's at the top on iOS or somewhere else the View menu, and under View you should have access to the tool window and then to app inspection. So you see now I'm in the menu of app inspection. Then I gotta select the task to which I want to attach this app inspection window. And once we got this, we have the background task inspector here. And from here you can now see this is actually the Ionic background runner plugin worker, and here is my cool ID that I use Capacitor background check. Actually, that is from a previous example I made. So this is the closest I got to debugging this on Android. Now on iOS, is my app already running? I don't know, it's probably not. So now it should be up and running. And we should be able to trigger this breakpoint here once we go into the background, because once we go into the background plugin implementation will try to schedule my task as I've set this to be automatically. So let's try. I'm going to the background and boom, the breakpoint was hit. So this is not something spectacular right now, but what we can do now is let's check out the ID again. So I don't want to make a mistake. This is now how you can manually trigger this. So my ID is Com Academy Runner Check. There is a line that you can now run for debugging, which looks like this. Let me prepare this, and I'm going back into Xcode. And in Xcode, down here, you can see that there's LLDB active right now. That means I can run some stuff in here, and I want to run E-L Objective-C -- void a function background task scheduler. And then the important part is that I want to simulate the launch for task with identifier, and that is followed up by Com Academy Runner Check. So I'm now pressing enter, and that should simulate the launch for task with my identifier. If at this point you see an error, then something is wrong. Maybe your background task wasn't scheduled, maybe you have wrong IDs, maybe something else went wrong. But until I got to this step, it took me a while. Also making sure in the P list the IDs are aligned. So there are many things that can go wrong. But if it looks like this, it's actually all good. At this point, we can, with this little button here, skip over or just continue our work. And the app continues working. Now in the background, it will actually try, and we see this right here. We see that the check-in event was fired. We have no check-ins yet. We have no check-ins yet. Where is it? The brush tool. Check-in event fired. No check-ins yet. Then we'll log out an object and then we say check-in saved. So all of this is coming from my background task as it was executed directly through our command. Now, let's get back to my application. So I'm going to bring this up again. Where is it? Here's the app. Let's try and go to the map page. And here is my map, and I try to load a check-in, and voila, there it is. With my coordinates, we have a check-in on that map. Now, this was a long way getting here, and it was actually quite complicated, especially because you can now try and use this in a real-world example. But you're gonna see that iOS will just randomly call your background task and not exactly at the times that you want it to happen. So the best implementation for this is not something like every 5 minutes I need to check the blood sugar with a Bluetooth device. That was brought up in the initial presentation of the plugin, but I think this is not the best use case for this yet. However, it is a great use case if you can outsource work from your application to the background runner, or if you have something that just randomly updates in the background. So when the user comes back to your app, they can use your app faster again. Alright, and that's it for today's video. I hope you enjoyed this introduction to the background runner plugin. Keep in mind, this is still a very early version, and if you look at the implementation, it's actually not too hard. It's pretty cool that Ionic has figured this out and made this work in the way it works, because we are now able to run these background tasks from just using JavaScript and a bit of setup in our applications. If you want to check out the code, link below the video where you can find the full example of doing the dispatch right from your application and also using this with the background mode. But keep in mind, if you try this in reality, your application might call the background task in about 5 hours or 8 hours or just once a day. So try to use the iOS debugging as I've shown you. For Android, it's a bit harder and I haven't found a good way to debug this yet. If you enjoyed the video, also of course make sure to hit the like and subscribe button, and I will catch you in the next video. So until then, happy coding, Simon.